Now let's talk about initial conditions. You remember that if I take the integral of a function, then I get what we're calling a general solution. So if I integrate this right here, I'm going to get x cubed over 3 minus plus c. So I say my general solution is equal to cubed minus x plus c. An initial condition tells us which one of these curves my function actually passes through. Because depending upon what c is, alright, my function will be shifted upward. So let's use the initial conditions to find out what c should be. So I know f of 2 is 4. So 4 is equal to 2 cubed minus 2 plus c. So 4 is 8 minus 2, which is 6. So that tells c is equal to negative 2. So that tells me that this curve right down here is my particular solution. And I write that as f of x, let me do it this way, f of x is equal to x cubed minus x. I'm going to put in the negative 2. And because I don't like the way that looks, I'll write it this way. So this is my particular solution. The general solution will have a plus c in it. The initial conditions help you see. And the particular solution gives you the one curve that is a solution to the differential equation and passes through the point. Now, let's see if we can find this particular solution. I tell you that f prime is 1 over x squared for x positive, and f of 1 is 0. So the first thing you need to do is to integrate and say, ooh, wrong pen, sorry about that, and say that f of x, the antiderivative, okay, it's the integral of dx over x squared, and I'm going to rewrite this as the integral of x to the negative 2 dx. So this is x negative 1 divided by negative 1 plus c. Or it's negative 1 over x plus c. The next step is I'm going to use my initial conditions. I know f of 1 is 0. So f of 1 is 0 means 0 is equal to minus 1 over x plus minus 1 over 1 plus c. Solving this for c, c is plus 1. So my particular solution is f of x is equal to minus 1 over x plus c. Now, I've already been told that x has to be good, so it never hurts to go on and restrict your domain there. Now, suppose vertical motion problem, and you're told that a ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. And we ask you a couple questions. What if I want a position of the function given the height s as a function of time? Okay, the first thing you need to identify, s is the position of my ball. And I'm given that s of 0, so when t equals 0, it starts out at 80 feet. And I'm also told that s prime at 0 is 64. How do I know that? Because s prime, you remember, is the velocity. Velocity, let me do it this way. And the velocity to start with is 64 feet per second. Now, where do I go from here? The first thing you need to realize, that's not given in the problem, but it will be, is that your acceleration due to b is always negative 32 feet per second squared. How do I find s prime out of this? I know that s prime of t is going to be the integral of double prime of t dt. So the velocity function be the integral of negative 32 dt, which is negative 32 t plus a constant. So this is my initial, or this is my velocity function. Now I know s prime of 0 is 64, so I'm going to use that as an initial condition. So I know 64 is equal to negative 32 times plus c, so c is 64. So I have a position function, or velocity function, is equal to negative 32t 64. But I'm not done, because I didn't ask for a velocity function, I asked for a position. Now I know that position is the integral velocity. So the position function is the integral of 9 minus 32t plus 64 dt. So when I integrate this, I get minus 16t squared plus 64t plus a constant. So I'm going to call this one C1. Now coming back up and using my initial conditions, I know s at 0 is 80, so 80 is equal to 0 plus 0 plus C1, so C1 is 80. So my position function is minus 16t squared plus 64t plus 80. So this is the position of the function as it relates to the height, as the position of the function in time.